So, Łukasz Langa is a core Python developer. He is the creator of the code formatter Black. I have been using that, so thank you. And he is the former release manager for Python 3.8 and 3.9. You have most likely been helping with other versions, so yeah. Fun fact, he is also a classically trained pianist. So, let's give it up for Łukasz and his talk, Permacomputing and Python.
Welcome to Permacomputing and Python. This is Daphnis Castle in Scotland, near Elgin. I visited there like 3 weeks ago. I highly recommend it, it's lovely. You should go. My name is Łukasz Langa. I usually say I come from the internet, but like since we're almost neighbors, like in Lily-Delio, I'm from Poznań, from Poland. It's in between Berlin and Warsaw, like almost right in the middle. It's a nice place. You can also visit. There's not much to see, but it's a perfectly nice thing, like a perfectly nice place to live. I make a point of not taking my passport with me whenever I travel in Schengen, so like, you know, kind of it's like wonderful to just be able to like have a local domestic flight, like, you know, to Estonia. Like I love that. Let's keep it that way. So yeah, today we're going to be talking about like serious matters. So, you know, there's not going to be much humor in the talk, so if you expect the jokes, like, you know, like, no. Like, for that, you need to like and subscribe to my podcast. Today we're going to be talking about perma-computing. And this particular term, it turns out, comes from a related term coined in '78 that's called permaculture, that was going to describe an approach to growing food, building houses, and essentially creating communities that mimic, that copy, that try to be like successful ecosystems on the planet. So the key for those systems is regenerativity and resiliency. And when things are resilient and regenerative, they're sustainable and therefore permanent. So permaculture, and our culture is like from agriculture really. So the concept stresses that you should collect resources at peak abundance so you can use them when you need them and there's not so much anymore. You should self-regulate, so like not use more than you actually need. Responding to feedback and change, so if something no longer works, just adapt, try something else. Minimizing waste and using small and slow solutions that just work in tandem, work together. And so permacomputing is a related concept that is oriented about resilience and regenerativity in computers and networks. I first heard of it in 2019 due to the company that makes those things. Those are musical devices. The little computer there like is called Norns, and the controller with the endless encoders and lights is called ARC. So I got those back in 2019, and it turned out that the company that makes them, called Mono, really cares about the longevity of their devices. So they both like really care about how they're built and how they're made so they will last for a long time, but also through open designs, both in software and hardware. Permacomputing is not exactly like permaculture in the sense that digital technology cannot be produced without waste. There's always inherent waste. So permacomputing asks us to recognize the inherent value that we have in devices, components, and materials that we already have, that we already use. To this end, when you want to minimize obsolescence and superfluous maintenance, that is a crucial point for systems that are intended to last. Even when well-built and well-maintained systems, both in hardware and software, will and do fail us. So permacomputing is also stressing how can we design, how can we prepare for the inevitable, that something will fail. And for us to have a productive discussion about this, I need to preface it a little bit. There's this very famous comic strip from 2016 published on the nib.com by Matt Bors, where this girl is posting on some social media that says Apple AirPods cost $159, but they can't pay taxes and decent wages to the Chinese factory workers. Then there's some gotcha guy appearing and says, you said this on an iPhone. We move back in time, and some guy says, cars should have seat belts. The same gotcha guy says, well, but you bought one, hypocrite. And then even in medieval times, somebody says we should improve society somewhat. But the gotcha guy says, yet you participate in society. Curious. Well, yes, so I will be advocating for permacomputing right now to you. And as you can see from both the stage and from the picture here, I'm a user of iPhones and MacBooks, so like pretty, standard, regular technology. Even though they're also closed platforms, so not only the sort of permacomputing longevity thing is not really their thing, but also it's not necessarily open for everybody to maintain after Apple gets disinterested in a particular outdated product. The MacBook that you see here, like that's one that still have DVD drives on them. As you can see, working outside, work from home in 2013 was not really viable. In any case, yes, I'm an Apple user. I also worked at a big tech corporation. Yes, like on the left is a photo I took on day one, on the right, like 4 years later. I spent over half a decade with that company. I was pretty happy at the time. Plus, I'm aware of the energy costs of AI, and as a musician, I can also relate to the critical voices around how unfair musicians are treated and how copyright is not really treated the same for whether you're an artist or you're a gigantic corporation that is scraping the internet right now. I know all that, I agree with most of that, and yet I use Claude pretty extensively. In fact, I have a maxed out max plan for the product, and currently my plan is graciously sponsored by Anthropic as part of my core development of Python, but I've been a paying customer before that, and if they cut me off, like I'll probably pay again. Like Anthropic, you didn't hear that, thanks for sponsoring me. The thing is this, I'm also using Code for sometimes atypical things, like microcontroller development, or for like a regular chat, because it turns out an agent is a better chat than the chat that you have online, because it can do things that the chats cannot. So it can access your GitHub, it can browse through your local file system, it can do a bunch of things that are really useful, so I do use it, even if it can be extremely frustrating at times. So here's an example where it cannot even sleep properly, because what it tried to do is to wait for a background process on my computer to finish. So it just issued a sleep 120 bash command, but the agent software itself timed out the sleep after 2 minutes. So now it's a failure, and now the agent was like, oh, the sleep failed, let's try something else, and it canceled the entire build, and I was like, what are you doing? So like there's plenty of things like wrong with how the agents work today, and the worst of them is like they just straight up lie to you, like all the time. Like, and if you catch them on a lie, or you're right to question those numbers, or oh, you're absolutely correct. Like those are things I hear daily from code, and yet I use it. So if you expected me to like now advocate for like selling your smartphones and going off the grid, not using computers anymore, moving to remote parts of Scotland, like this is not that talk. You can relax. Because I'm not a radical, I just care about user agency, and what I mean about that is that everything can be radicalized pretty quickly, and some materials on permacomputing in particular, if you Google it, if you search for it, will literally call it an anti-capitalist political project driven by anarchism, decoloniality, intersectional feminism, post-Marxism, degrowth, and ecologism. Well, that's a quote. Sounds plenty radical to me, and I'm in particular not keen on romantic notions of communism expressed by people who never lived under an actual communist regime. So instead, I'd like to focus on practical notions around sustainable computing. As the longer I'm part of this industry, the more I think this is a key issue for us, because user agency cannot be treated for granted. We lose it all the time. It can be taken away when devices you own can be inoperable remotely. Yes, you may receive a refund from the corporation, but your utility is gone and you are creating waste. That's not good. User agency gets taken away when your data ceases to be available to you. Firefox essentially bought Pocket and almost forced Firefox users to use it. And that was like a little bit of a controversy at the time. But then they actually shut it down, which caused even more controversy because some people started depending on it when Firefox really pushed it hard on their users. So sure, you can migrate, but now you have to migrate, and you might not be able to do it at a particular opportune moment for you. And if you miss the window, your data is gone. And what if you did it 300 times, right? So there's literally a website called killedbygoogle.com, and just on this front page right here, I list just the most recent things that Google shut down. There's Chromecast, Google Podcasts, and Google Domains that affected me personally. So obviously it's a business doing business decision, and as a Google shareholder, I am essentially also gaining from their decisions not to pursue projects where there's no business model. I get that, but at the same time, this is nothing but bad for the users of those products. But user agency can be also taken away in very subtle ways. So nowadays we increasingly have almost unreasonable complexity within our systems. So Bert Hubert here in this 2024 article already says, and I quote, "We are likely looking at over 50 million active lines of code to open a garage door." If you count essentially all the dependencies and all the server code, yeah, that's a reasonable estimate, and this is scary because not only is this how Bert is arguing a security vulnerability, it is essentially impossible to vet 50 million lines of code, but also if the manufacturer of your garage door opener ceases to maintain it, what chance do you have to actually take over that maintenance to keep your garage door opening? If there's 50 million lines of code, this is not possible. Better yet, if you're now using LLMs, if you're using pre-trained models, now you cannot even really debug them very effectively because all of those if-elses with the weights are hidden from you. There's no logic that you can trace with that debugger through. It's all becoming very abstract to everybody. So user agency can be taken away also by subtle ways. But even if we did everything correct, even if business was always making great business decisions, and our software was small and maintainable, and our hardware would never fail through our faults, the universe is stacked against us. Entropy manifests in so many ways. And to illustrate this, I'm gonna go present you maybe a bit of a far-fetched example. So here's Earth. You can see continents colored so that you can still recognize them. When we move back 66 million years, at that time, the Alps did not exist yet. That origin has not happened yet. So Switzerland would have nowhere to be because the mountain range was non-existent yet. You know what else did not exist anymore? Dinosaurs. They already went extinct. So during the entire lifespan of dinosaurs, they never experienced the Alps. A mountain range was too young for them. And to this day, we only have around 100 relatively complete skeletons of dinosaurs. Yeah, we have thousands of partial fossils from stuff, from places. That's great. But only 100 of complete specimens of this is how a dinosaur skeleton looked like. So there's a fun conspiracy theory that says humans are not the first civilization that lived on Earth. And you know, like there's no evidence for that, obviously, and it's not really super likely that that might be even true. But we can devise a fun thought experiment from that. What if that were true? Would there be anything that we could find around us from hundreds of millions of years ago that would indicate that there was, in fact, a civilization living on Earth? And the answer is no. Like, even continents shape, they're created and smashed together, and they're supercontinents after, and they smash together, like, you know, split and smash together again. There's nothing that would survive that we could interpret as reminders of like old civilizations. Like a little ironically, because if they would be very like permaculture, solar punk, like perfect, they would not really leave anything in the fossil record, and if they would be very irresponsible, they would likely be very short-lived. So the time span for us to look on would be very tiny. In any case, that is not really useful for today's conference. I know 60 million years ago it's a little long, so let's shrink the time span that we're talking about, like say 100 years. So this is the so-called centennial light, like a light bulb that is probably the longest operational light bulb on the planet right now. It was first lit in 1901 at the Livermore Pleasanton Fire Department in California. It was originally 60 watts. Now it's more like a 4-watt light bulb. What's the reason for that? Well, all the components in it, including gas inside, like all of that is aging. But the interesting thing for this particular conference is electromigration. This is a phenomenon which makes little atoms of like metal to move when current is applied to the metal. When you have current flowing through metal, atoms will also travel with it, and that can create places where there's a lot of it and other places where there's not enough of it anymore to like sustain a circuit. So for chips, this is an actual consideration that electromigration will cause chips to fail. And ironically, the old ones that were relatively chunky, like the transistors there were really big, they are more likely to survive into the future, while the new ones that have very high current density and also smaller conductor dimensions, those will fail us sooner. And it can actually show up to you in many ways. Like for example, with bit rot. If we not even think about 100 years, but think about 20 years, will your data on the devices that you have survive 20 years into the future? It might or it might not. This is actually a photo I took and lost in time because I didn't have a backup of this particular thing, and then when I tried to open it years later, like, well, it was gone. So this happens all the time. But 20 years, that's also a long time. How about 2 years? I used to own a MacBook like that when they still had like replaceable batteries. That was great, and you actually use this feature because they tend to bloat really badly, which is not safe, by the way. Mine did not bloat that badly, but it did, so I had to like exchange it a few years after I bought the laptop. But the laptop failed even before that. And how did it fail? Well, because underneath the battery, you had this ribbon that is right here in the middle. That ribbon connected the logic board to the so-called top case that has the keyboard and the trackpad. And it's a flexible ribbon, and the battery used to just push on it. So if you kept your laptop on your lap, in time, those ribbons would break. So I sent the laptop back to Apple, and I'm like, well, this is going to be like a 50 cents of a replacement, right? Like it's just a simple ribbon. And no, it was a $120 replacement because it turns out that that ribbon is like soldered onto the top case, so the entire top case had to be replaced. So not good. Not even 2 years of a lifespan on a device that was designed by a company that specializes in this. Not a great track record. But even if we did all of this correctly, even if all of our planned stuff went great, there's plenty of unpredictable events. And this is the most depressing slide of this talk today, so like brace for impact, but let's get this out of the way. What if you dropped dead just right now? I know, like, it's a heavy question to ask, but like, imagine, like, if you have a significant other, if you have parents or children or whatnot, would they be able to access your devices and your data on those devices for, first of all, like sentimental reasons, but even for practical reasons? Could they do this or not? Because in history, for the entire history of civilization, when somebody died, like my grandma died and her children gathered to go through her stuff. They discovered some pictures that they never even knew were taken, and some other objects that are now really treasured mementos of the person my grandma used to be. And that's beautiful. But nowadays, we're sort of paranoid about people hacking our computers, right? About people scamming us, about like malware and stuff like that. So all those devices are pretty locked down, encrypted, and you have Face IDs and Touch IDs and secure enclave chips and so on and so on. So if you don't plan for it and you suddenly disappeared, this might be really sad for the people you leave behind, because they might not ever feasibly be able to access the photos you took on your phone, or the emails you wrote, or like some other ways in which the lives of your loved ones would still be a little bit better if they had access to those things. But okay, relax, you're not dead yet. What if there was a war? I know, like, we're in Estonia here, like, I'm from Poland, so it's not really probable that something's gonna happen, but it is certainly possible. So this is somewhere in our minds all the time, right? If there is a war, even if you are not actively fighting, what can happen is you might lose internet access, you might lose electricity for days on end, you might even lose running water. I work with Serhiy Storchaka, who is currently, right now as we speak, in Ukraine. And those three commodities are not guaranteed for him at any moment. So imagine, like, what would happen if we didn't have internet access for 3 days? Would all your devices still be as usable as they are right now? Could you still be doing the things around your house? I don't even mean the job. Like, would your house still function exactly as you know, like as you expect it to? Like, would the traffic lights in your city go dead? Like, what will happen then? All of this compounds because we got pretty dependent on technology as we live our lives right now. And what if you had to flee home for other reasons, like there was a fire or there was a flood, right? So like there's natural disasters, like some less sort of like scary but still very severe reasons for you to having to leave home right now. Some of the things you left behind you might never get back. Would it be inconvenient, or would it be really hard later on to recover from that situation? If you lost your birth certificate, like I know, like Estonia in particular, like very digitized, that's great. But there are still things that if you don't plan for it, losing a Google Authenticator, like abruptly, might be really disruptive for you. And finally, what if you're just silly? What if you just make a stupid mistake and overwrite a file that you were working on with an earlier version, or misconfigure your software, and what it will lead to is it's doing the wrong thing over an extended period of time, and then you find out too late that stuff is not going well. All of those things can, be related to our conference, to Python, to technology that we're using for work. But they can just be like life things that you as an adult should really think about. So for this other kind that I'm going to be talking about, you should read this book. It's called Practical Doomsday. It's by Michał Zalewski, who is like of Polish descent. He lives in the US now, goes by El Kantev, and he's probably mostly known from his cameo in Matrix Reloaded. Well, he didn't appear there physically, but his SSH-1 exploit did. Like, it's literally on the screen, so you can see it. Like, good guy. In any case, permacomputing sounds like a great idea, but does it have any concrete principles, any concrete advice to what you should or should not be doing? Yes, let's go through those, like using some practical examples. And since Lotta brought up my classical training range for my stage piano. It's a digital piano because like people don't really like you playing the piano for hours on end every day in your house. So if you love your loved ones, being able to connect headphones when you're learning a piece is just a sign of love, you know, like, you know, and when you already know how to play something, yeah, that's fine, you can play it for them, but the learning, not so pleasant to be around when it happens. In any case, that was one of my first purchases after I started being active in the industry and having a job. So this guy is now 20 years old. I bought it in 2005. So the principle here is design for maximizing hardware lifespans. 20 years, that sounds like a decent chunk of time, especially if you take into account that there is plenty of mechanical elements in an instrument like that. So they wear out, they break. And in fact, that happened to me multiple times. But Yamaha is our company that is like now 200 years old almost. And they designed it with repairability in mind, like designed it for a long lifespan. So like, you can literally open the instrument like popping a hood from a car. It has hinges on the end, so like, you know, the top will not fall off, like it just stays where you put it. The cables run long enough for that motion to be just, you know, normal, you will not rip anything apart. And they literally tell you how to dismantle all the keys, which I did here, which is why they look a little strange. So I did this maintenance over the years a couple of times, and the instrument will likely go on for another 20 years. There's no reason why not. Like, you can exchange speakers if you want to, you can like desolder and solder new caps if you need to. So like, it is all perfectly repairable. There is really a service manual for it as well. A little bit of a less great example in repair and reuse are those beloved Sony's XM3s that I really liked, but the fake vegan leather like cushions wore out pretty quickly. So I bought replacements. I installed them. They worked for 2-3 weeks, and then the adaptive noise cancelling started feeding back on itself, which was extremely unpleasant. Tried to like install the cushions again, it didn't work. The entire process of repair was not something that Sony expected end users to do. So the product is now in the bin. It is pretty sad. But Yamaha, you might have heard of them. Like, they are really good at those things instead. So those are like synthesizers. They call them tone generators because those are ancient devices. Both of them are from '89, so they're almost 40 years old by now. I bought two because what if one breaks? Like, I need to be able to replace some components in them. And in fact, I already exchanged the screen on the left one just so that I could use like a modern high contrast one. But to do this, I had to open the thing. And when you open an old device like this, you're going to see like plenty of chips. But those are the chunky boys that I told you about. Like, they have really big transistors. They are very easy to desolder even at home, and they do very limited things each. So they're pretty easy to replace, even if Yamaha would no longer produce those chips. Providing a replacement from first principles would be pretty feasible to do. So this sort of notion of being pretty like local in what a particular component does and using low-tech solutions, that is also a very big important tenet of permacomputing. And in fact, those chips that you have here, they're pretty coveted right now, also to extract them and install in new devices. People do this all the time. This is another device that I have, which took a chip from early Sound Blaster cards, so that now on your Mac, you can literally recreate the sound of how The Secret of Monkey Island sounded on a DOS PC in 1992 or something. So it is extremely popular. There's like very many musical instruments and other things that are hunting for those chips, like those vintage chips, and using them in new devices. Speaking of new devices, you already met Norns and Arc. That's great. It's a boring name, but it's what it is. So Norns allows you to write scripts in Lua. Not this conference, but like, it's still fun. People can write scripts there, and that's computer that was devised in 2018, so it used the Raspberry Pi Compute Module 3 originally. Now there's new revisions using newer compute modules and whatnot, but Mono, the company, says that the computational complexity limit on the platform, even on new devices, is set such that they will like achieve like ceiling, a headroom that is the same as the first device that they ever released, just so that all of the users of Norns have a level playing field. And that allows you to like fight this sort of upgrade culture where you create e-waste because people are like, oh, I need to have the newer version of a thing. It's just music, like what the complexity here like allows you to do, what the Raspberry Pi 3 processors allow you to do, is plenty enough. You can do amazing things with that. So yeah, Mono is pretty serious about that, including allowing you to actually just design alternatives. Like a friend of mine from Texas did exactly that, and we built one together, and I use it with a newer Raspberry Pi version, which is great. Because not only does it allow you to experiment with those designs, but if Mono went away, for whatever reason, would all this software effort to create Norn scripts by the community be wasted? No, because we could still be able to create replacement Norns for years to come. And in fact, you met Ark. This is Rin. This is another project of the guy from Texas for which I wrote software, because this is a modified version of CircuitPython that's on there. So you can write Python scripts to do whatever you want. Like you can make it a MIDI controller, you can make it a DaVinci Resolve controller to like color grade, or you can make it the most overpowered Pomodoro timer ever. Like it's up to you because you can just write Python. And this finally, 30 minutes after we started the talk, brings us to Python. Right. There's going to be some code in the slides after that, but they're for illustration purposes, don't worry about it. A question I get every now and again is, Łukasz, how was it that you first found Python? And like, what was it that you liked about Python? Why are you now working for the PSF on Python? There are other things that I could be doing for better money, so why? Why Python? And obviously, initially, the thing that gets you attracted, in my case, like some, 21 years back, was the concise syntax with significant white space, so it all kind of looked uniform, and also like being able to import everything and make very complex things happen in like 3 lines of code. So yes, like we all go through it, and the fact that it sort of reads like English, so that was very friendly compared to like C and stuff like that, like amazing. But if you spend enough time with a piece of technology, you start seeing the less obvious things that make it really unique compared to other things. And for Python in particular, I learned that for me, this is the interactivity of it. So it is easily editable and debuggable, including in the deployed state. So even on a microcontroller running MicroPython, you can connect through a serial console and invoke a REPL, invoke an interactive shell, and interact with your microcontroller software to see what is going on with it, which is incredible. If you have like some Raspberry Pi running like some ad blocker for you or whatever home assistant thing and so on at home, you can literally change the PY files there because Python comes with source code, so you can read it, you can edit it, and it has the interactive shell, it has breakpoints, it has all sort of things where you don't need any additional tooling. And now with the new Python, you can even connect to a remote process to debug it without it being have to be restarted. So it works pretty well. So that's, I think, the kind of core thing that makes this viable for long-term computing, to make sense for us, like to be able to maintain software beyond where the original authors are willing to maintain it. And we have support for gold standard file formats that like HTML, XML, CSV, and SQLite, and all of them sound extremely boring to you, right? Good, that's the thing. Nazim Nicholas Taleb like coined the term Lindy effect. That essentially means like if something was around for a long time and it's still around, that is a good predictor that is going to be around for a long time from today still. So using very well established formats that are easy to parse is crucial for this, and for long-term computing, really important. And for formats that we don't support natively as a built-in battery in the standard library, we can use third-party libraries, like Pillow for image formats. And in fact, I believe that at least a subset of Pillow belongs in the standard library. And for this exact reason why we gathered here for this talk, that I think that if you have some device and like the original maintainer goes away and you get to this device 10 years later and you're like, oh, I wish I could add some image processing to it for whatever reason that you might need it for, you might not be able to pip install Pillow for that ancient now Python version on an embedded device. So if Pillow was guaranteed to be there for every Python version, for every Python install, that would be much better. That would essentially provide us with, I think, core functionality, being able to read PNGs and JPEGs and write them back. Like, I don't think this is too much to ask. So I might have strategically put this slide here because maybe the Pillow maintainer is here with us, so talk to me after. But let's move on. So Python, it's fantastic because it also comes with built-in networking. So this 80-line script is somewhat of an example of like me fighting for permacomputing against the current like trends of everything. So there's an online platform that I use for stuff, and it doesn't have a really nice, good way of backing up everything, especially if you want to version what you backed up. So I wrote my own in 80 lines, and this is software that can easily saturate a gigabit Ethernet link with one thread of Python. So pretty fast. Literally, your SSD speed is now your limit. So what am I using Python for in the sense of this talk for permacomputing? Use it for everything. I use it for everything, like also in the sense that what you see here on this picture is all Python. bpytop here on the left shows me graphs of what is happening on my computers. The Mandelbrot set in ASCII and in the image is Python. In fact, like the ASCII is not just an ASCII image. This is Python code because Python has significant indentation. So if you format your code as a Mandelbrot set, it will generate a Mandelbrot set. That's just natural. But you know, now you know. Actually, it's not a joke, right? This is actual Python code. Yeah, so this is running Python 3.14, generated an image in my terminal, but even the shell that we have here, it's called conch, XONSH, which is a shell like Bash, but instead of shell scripting, you can just write Python in your command line, in your RC files. Think about it, it's amazing. If you have an environment variable called path, now it's a list of Python paths. Amazing, I love it. Like aliases is a dictionary of keys that are strings to strings or Python functions. Amazing. Love conch. Also love it because it's written in Python. And you know, Python works on Windows. So conch also works on Windows. So you don't have to use PowerShell on Windows. You can use a Python shell on Windows. By default, you can configure Windows Terminal to just start with that. So you can have a uniform environment for development across macOS, Linux, and Windows. I think that's incredible. Python is incredible. And you know what? It saved me some personal data that I wouldn't be able to recover later. Because when I lost that photo that I showed you before, I wrote this little piece of software. It's stupid, but like it is very effective, where it literally would go through a directory, like hash every file, and just store it in a SQL database. So the SQLite database stores this information so that later on you can run this tool again and it will check whether the hash has changed. What do you mean, Łukasz? But like files change, right? That's normal, like the hashes will change. Yes, but you know what else will change when a hash changes? The timestamp for last modified on the file system will also be updated. But what if the hash of the content changed but the last modified timestamp did not? This is an indicator that something somewhere went wrong. And amazingly, this tool ran semi-regularly by me, found multiple examples in the 13 years that I've been using it of things going wrong exactly the way I described it. Sometimes the nice synchronization services that we're using will be the cause of that exact failure mode. So we can use Python for those sort of things, for everything. And one particular thing that I really cherish and would hate to lose is my notes. My long-term memory is not so great, so I am like a really radical note taker. Obviously, I don't have 1.3 gigabytes of text in my notes. The notes are actually formatted in this way where there's this text bundle. It's an open format that has Markdown, and it has JSON for all the metadata, and it has attachments for all the images. So you might imagine that there's a bunch of PNGs there. So 1.3 gigs. I store all of that in Git. And because all of those are just files on disk, easily accessible, open as anything can be, I can use software like FS Notes. It's an application, by the way, maintained by a really nice Ukrainian guy that works on Mac and iOS, where it's just a really nice interface over this plain text data. It does the tags for me automatically so I can organize my thoughts. It will show me the images and like pre-format like the Markdown just a little bit. But because I have all of this as just files, I can make my Git synchronization really custom and tailored to what I want. Because I use Git for synchronization, it turns out for this purpose is great, because it not only synchronizes without any paid service, but also it stores history, which it turns out you might want to have that. It's amazing. And this data format also lets me to convert some of the nodes tagged public to the website that you can go to and see like, okay, that's Łukasz's website. So that's literally generated from those nodes. Anytime I change some nodes, this will automatically be synced to Git, and this will automatically be picked up by Netlify, which automatically runs like a static site generator. Again, I wrote because it's not even 1,000 lines of code because it's really tailor-made. And boom, there's a new version of the website. I don't have to do anything. And all of this is independent of any particular big corporation and closed walled garden system, which would be impossible if your nodes are stored in a nice app where you don't have access to them and you cannot build on top of your data set. It's your data. You should be able to do stuff with it. And I, in fact, do a lot of stuff with it now, like write plenty of one-off scripts, like to analyze my node, like find trends, like track habits, and so on and so on. And these days I even use Claude Code to help me search through my notes, because you can ask it questions like, well, some of my oldest notes, especially, they're in Polish, they're not in English. So sometimes I'm like, I think I covered this at some point, but how do you grab for it? You don't know what phrase I used for this particular topic. So you can just ask Claude Code, like, look, this is my directory of my nodes, write a script or do whatever, like go through all of them and find me where I'm talking about this topic. And it will. So like another weird use case for AI agents, but its use case on your local data would not be easily possible if that data was stored in some application where I wouldn't have access to it. So, Python, great for permacomputing, you should use it. Well, but not everything is perfect with that. The language has some tensions with permacomputing, so let's just talk about them for a bit. So first of all, it's an interpreter language. So to make the dynamism that we all love possible, it is essentially a machine for pointer chasing. Like you're gonna have plenty of like memory addresses that then the CPU has to follow to make like accesses on objects, attributes that end up being lists and indexing those and so on and so on. That is way more inefficient and can never be as efficient as analyzing this path and just pointing at the right thing in one step that compiled languages do, like Rust. So we are paying the price for the dynamism, and that is essentially a little annoying for low power systems, like solar powered systems, things that you might want to put in remote places. Fortunately, MicroPython turns out to be more energy efficient, like so for microcontrollers, this is actually like where I would go and it's great. But for CPython, we're not doing that great. But there are plenty of faster Python initiatives, and now like hopefully we're gonna see 3.15, 3.16 having the JET infrastructure that we already put inside CPython bear fruit. So hopefully we're gonna see like performance upgrades stemming from that. But even the one big change that we've already seen with free threading, that's a little surprisingly more energy efficient as well, because in theory it's the opposite, because now you're using more cores, so they're gonna create more temperature, they're gonna do more, so you're gonna draw more wattage from your power source. But there is plenty of situations where a computer system is talking to something else, so there's a larger operation that is now waiting on the slowest bit, like even training models. Like it's doing the bulk of the job on like GPUs, right? Like, you know, like, or the equivalents in the data center. But then when the stage of training ends, and there's stuff that Python is doing on some server, if we have to wait for it longer, we're literally wasting all this power that those GPUs are now just idling through. So being able to do that faster with free threading actually gives us meaningful speed-ups. We're not like exactly where we want to be there, but we're moving in that direction. So this is a consideration for us right now. And it should be, because Python is the language that AI writes. And Python is the language that we write AI with as well, right? So it's very important for this particular use case. That got me thinking that like, it is a little ironic, right? Because AI is still like very new, so it sort of drives up this upgrade cycle, you know, kind of need. It makes like fighting obsolescence hard, because the hardware that you had a few years back might not be able to run modern models anymore, or will be too slow to train new models, and so on and so on. So we need to constantly upgrade. So what about that? Well, I think that we are still in the research and development phase of AI, so for now the consideration is not about like making it maximum energy efficient. I am aware that like, just like the Bitcoin boom a few years back, like some of what we're doing with AI is now literally a little bit of a, you know, boiling oceans for no reason. But it's the R&D stage, so I will allow it that like we need to be able to experiment with it, like, and to grow the base of what we're attempting to do, and then we can make it efficient. We will need to make dependency management more efficient as well, because the frugality aspect that Bert Hubert was talking about, like, is a real problem everywhere. And it's not just Python specific. JavaScript has the exact same issue. Ruby has the exact same issue. Like, if you're building complex software, you're gonna have some dependency management. Like, for Python in particular, what people often complain about is packaging, right? So, especially the deployment part of it. So, how do I give a ready-made application to the user, especially on mobile, especially in like the sort of newfangled devices that we all use. So for this, there's also community involvement that makes stuff better. So you might have to like listen to Grandpa Łukasz tell you like, not long ago, we couldn't even depend on binary wheels to be ready for your platform on PyPI. So if you picked install NumPy, it would try to compile it on your machine, which was not only super wasteful, but also was likely to fail because you didn't have the exact like system libraries and compilers like on your box. So we are doing better right now with stuff like CI build wheel. The situation is constantly improving. And for mobile devices and cross-platform packaging, a project called VMware, now sponsored by Anaconda, is providing that. Like, it is bridging the gap so that you will be able to build Android and iOS applications directly in Python, but even today you can just package ready-made ones for usages as a Mac app, as a Windows app, as a Linux Flatpak or something. So that is already possible, as is Pyodide, which is Python in the front-end browser, a great piece of technology. So we're making this thing better. It is not where it needs to be, but like we also have it on our radar. But as a language that is supposed to be used for extended periods of time, our support window might appear a little short. If you're thinking about 20-year lifespans, a 5-year lifespan might not appear very long. And I sort of contributed to this by changing the recycle to be annual. So what about that? I will tell you, like, I'm going to be the first to tell you that it was amazing to be able to dig out my first Java project ever. That was of any complexity, did some audio video stuff from 2004. and be able to run it on this MacBook with no changes, because there was an ant.xml file. I just built it and it ran exactly unchanged. This is not the state of Python today, and it's sort of a problem. I do understand that like we need to do better about that. We do have improvements there too. Just recently we switched the regular, the green bug fix security, the bug fix stages of the Python life cycle to be 2 years instead of 18 months at first. That might not seem like a long time for 6 months, but there's a lot of bug fixes that you are now gonna get in a maintained version of Python that you wouldn't otherwise. And even our backwards compatibility policy gets now more conservative. We used to say, if you want to remove something from Python, you cannot just remove it in the next version. You need to slap a pending deprecation on it, and then the next version you modify it to be a deprecation warning, and then 2 versions from the initial pending warning deprecation, then you can remove it. But now that's only 2 years. So earlier in 2025, there was like an amendment to this backward compatibility policy that says like, hey, you don't have to do 2 years. The suggestion now is to like leave it be for 5 years. If it doesn't make Python maintenance terrible for us, just leave it be for 5 years. Actually, there is a section there called soft deprecation that now advocates for developers to only mark things deprecated in documentation. So they don't even raise warnings that something is deprecated. And you're thinking, why not? Well, because very often it is the end user that is faced with a deprecation warning, and they're in no position to really do anything about it. So you don't want to like just spew warnings that are not actionable by users. So the backwards compatibility policy is improving for us to maybe hit this elusive goal of being able to run 20-year-old programs at some point. Will it be amazing? I think it would. Because Python, I strongly believe, is a public good. It is not only open source, many programming languages are, but this one in particular is not controlled by a single corporate entity. So if Meta stopped sponsoring my position next year, Python would not cease to exist. If Microsoft fired a team that works on making Python faster, Python will not cease to exist. Better yet, not even the project to make Python faster will cease to exist. It will continue through those same people working at different places, continuing their work. So we are not dependent on corporations for longevity. We are dependent and we are thankful for their support financially to allow you to have Python develop as fast, get better as fast as it does. So we're not enemies with the big corporate world. We kind of acknowledge that this is a symbiotic relationship right here, where it makes sense for them to invest, and we're happy to take their money. But we are independent. So I think this is something that you should consider for longevity, that Python is not going to be a rug pulled from you anytime soon. So you might think, okay, so what can I do as a customer, as a consumer, to make my life around me a little more permacomputing friendly? Well, there's a bunch of things that I'm just going to quickly suggest you can do. So, first of all, those backups thing, I know, Grandpa Łukasz says, you should really keep backups, but seriously, the number of times this saved me is just crazy. And most of the time, it was me doing harm to myself, and then backups saved me. But backups means a snapshot in time of your state of your computer. So all the file synchronization services like OneDrive, Dropbox, Google Drive, and iCloud Drive, they don't count. They're great, but if you do something stupid to your data, they will happily replicate that mistake everywhere, and now you lost it everywhere. So real backups, really important. Own your hardware, software, and data. So make choices that will not keep your data hostage to a single corporate entity that might just decide we don't want to maintain that thing anymore. And even for hardware, you might want to be able to repair things, to fix things. And ironically, this iPhone 16 that I have here, is having a pretty good repairability record. So you are able to buy stuff on iFixit.com, to just replace the battery and whatnot, or a faulty USB-C port and so on. So Sometimes the answers to those things are maybe not so obvious as you would think. Like, obviously, framework laptops are better than like MacBooks in terms of repairability, but still, like, it is what it is. Like, just think about it. Question the agriculture. Like this Apple Watch, the least repairable thing that I own, probably, is running its own. It's 5th year now, and I keep using it, and it's fine. Same for this laptop. It's the best laptop I've ever had, and zero pressure to actually upgrade it right now. I love that thing. So yeah, like I don't blame you if you want to have the latest iPhone every year. It's fine, but maybe you don't have to upgrade everything so soon. Taking care of and using what you already have is a virtue on its own. And yeah, choosing repairable products, I already mentioned that, like, is important because then you can fix trivial issues and keep using your things into the future. And software subscriptions are a way to, you know, kind of remove your agency. Like, if you can buy a thing, buying it is more expensive, but then you're not going to be surprised by price hikes or changes in licensing, or your data now being used for like purposes that you might not have agreed to initially, but now you have to agree to the updated license, because if you don't, they're just going to cancel your subscription. So just think about it, like, okay, I have a bunch of subscriptions, but be mindful of what you're subscribing to. And keep learning. Like, when I first started, like, you know, with like thinking about those things, I was not able to like solder anything. I was not able to like repair anything. And now I'm still pretty bad at it, but I did repair a bunch of things at home, like, instead of throwing them away. So it is a skill that you can gain. But that's like